Good morning. Today we are going to solve the problems on unit number 3, and that is from examination question paper 2019. Now for this unit number 3, you can refer playlist. So you have to go to playlist. And in that playlist, you can have this engineering mechanics subject. And in this engineering mechanics subject, you can go with basics and some problems which are related with your unit number 3A part. So I have solved some problems that is from university papers, that is of 2015 patterns. You can refer this. Now we are going to solve the problem that is from 2019 pattern of SPPU. So now this question paper, this is from December 2019, and we are interested with the problems which are related with unit 3 part A. Now you can see the problem is given. The weight of the cycle is 500 Newton, which is act at the center of gravity G, as shown in figure. Determine the normal reaction at A and B when the cycle is in equilibrium. So now we have given this diagram, and now you can see we have reaction at this, at A, which I can say VA. We have reaction at B, which I can say as VB. And then weight that is acting G, and that value is given 500 Newton. So we have this value as 500 Newton. So now we have to solve this. So if I will draw free body diagram for this, then we have free body diagram is in this fashion. So we have this as VB. We have reaction over here, VA. And then we have this force acting, that is 500 Newton. And this is 0.5 meters. And this is 0.7 meter. And we are interested to find the normal reaction at A and B, which is VA and VB. So now we know we have for this equilibrium conditions for parallel force system. Now this is parallel force system because we have two reactions which are VA and VB acting vertically upward, and then we have force which is 500 Newton which is acting vertically downward. So now we will take moment about A0, we will get value of B. So moment about A equal to 0. So we have clockwise, so 500 into 0.5 minus, because moment due to VB is anti-clockwise, 1.2, which is equal to 0. And from this we will get value of VB, and that is equal to VB equal to 500 into 0.5 divided by 1.2, and we have this value that is equal to 208.33 newtons. Now we can apply another equation to find out value of VA. We can apply Fy0, or you can take moment about B0. You will get same answer. So we have VA minus 500 plus VB, and that is equal to 0. And from this we will get VA equal to 500 minus 208.33. And from this we will get value of VA, that is equal to 291.67 Newton. So we have a reaction, normal reaction you can write. Normal reaction at A equal to 291.67 Newton. and normal reaction at B, normal reaction at B equal to 208.33 newtons. So we have to write answer in this fashion so that it will be easily visible for the examiner. So now we will go to the next. So this question was asked for 7 marks. Then we have explained the hinge, roller and fixed support with maximum number of reaction exerted on it with suitable examples. So now we will say we have simply supported roller and fixed. So hinge or simply supported we have in this fashion, and two reactions act on it. First reaction perpendicular to the plane of the support and another will be perpendicular to the first. So we are going to be with two reactions at simple or hinge support. So I can write simple or hinge. Then another we have roller. So this support will roll in the plane of the surface. So we have only one reaction which is perpendicular to the plane of surface. So we have this, that is a roller support. And third we have fixed support. So now in this also we have three reactions. One will be perpendicular to the plane of the surface. Second will be perpendicular to the first. And third will be moment. So we are going to be with three reactions in case of fixed support. So we have this will be fixed support. So this was asked for 3 marks. Then we have next find the reaction exerted at A and B on the sphere of 200 Newton kept in a trough as shown in figure 2A. So now you can see this sphere is touching your trough at point A and at point B. So we have two reactions. First reaction, we have normal to the trough at point A, and another will be normal to the trough at touching point. And so we have this will be RB and this will be RA. Now try to understand, this is most important. We have, first I will talk about A. So we have reaction perpendicular to it. So we have this is RA. So this angle I have 90 degree. Now it is given. So you can see we have this angle. This is given. This with horizontal it is given as 5 degree and we have somewhat like this. So this is given 5 degree and this angle, this was given 45 degrees. Now if we have to find angle with horizontal, if I will plot horizontal over here, then I will get angle of this inclined portion of the trough. So this angle I will get as 40 degrees. Now if I will extend this RA and I will extend this point, then I will get this angle made by reaction A with horizontal. So 40, this 90, so this will be 50 degree. So angle of RA with this inclined 90 degree and with horizontal, we have this angle as 50 degrees. Now at point B, you can have this, if I will draw this diagram. So we have in this fashion, so we have this will be again normal to it. So we have this as 90 degrees. And then you can see this. So this will make angle 45 degrees. So if I will draw horizontal I have below now. We have horizontal like this and this angle is 5 degree. So if I will draw horizontal below, Then we have in this fashion. This trough, this. It is making angle 45 degree. And we have this angle is given 5 degree. So this angle with horizontal, I have 50 degrees. Then we can extend these lines. And by extending these lines, I will get this angle. This is 50, 90. This will be 40 degrees. So I can have this. And we can have this angle with horizontal. This angle I will get as 40 degrees. And now at the center, we have its weight, which is given 200 Newton. Now, if I will draw a free body diagram for this, then I have this as a circle, your sphere. And on this sphere, we have one reaction, which is RA, and this is making angle 50 degree with horizontal passing through the center. Another reaction we have, which is perpendicular to this, making angle 40 degrees with horizontal, and then 200 Newton, which will act at center. So now if I will draw the diagram, then I have diagram in this fashion. I have three concurrent forces. So we can have like this. So this is making angle 40 degrees. This is making angle 50 degrees. This is RA 500 and this is RB. And now if I will apply summation fx0, so I have this as RA cos 50, then minus RB cos 40, RA cos 50 minus RB cos 40 equal to 0. Then we have another equation, summation Fy0, which will be RA sin 50. Then we have plus RB sin 40 minus 500. Sorry, minus 200 equal to 0. And then we will get it as RA sin 50 plus RB sin 40, and that is equal to 200. So this is equation 1. This is equation 2. So solving equation 1 and 2, solving equations 1 and 2, we get. So what we will get? So we have RA 153.21 Newton. So RA 153.21 Newton and RB equal to 128.56 Newtons. Now you can solve this by using Lami's theorem, but you should be very careful with this. So you have to show all forces in Lami's. You have to show all forces away from the joint. So this will be my RA, making angle 50 degrees. And then I have RB will go on this side. So this will be RB, making angle 40 degrees. And then I can write RA divided by angle between other two. So this angle So sine 140 equal to RB divided by this angle 90 plus 40 sine 130, which is equal to 200 divided by this angle. So total we have 180 minus 50, 40, 90. So this becomes 90. So sine 90. And by solving this, if you solve this, so I will just see the answer. So sine 90 is 1. So 200 into sine 140, 128.56 Newton. So sorry, here we have values. RA we are getting as 128.56. No, sorry. This RB upon 140. We have this will be 140. This is RB. So we have this as RB actually. And this we have RA. And therefore RA we will get RB now we will get equal to 200 sine 90 is 1 into sine 140 and we have same value 128.56 Newton. And then RA we have this angle is 130. So RA equal to 200 into sine 130 and we will get it as 200 into sine 130 and we got 153.21 Newton. So you can solve by any way, but you have to keep in mind we have to take all forces away from the joint. So if I will say this will be G joint, here we have to show at that joint only. So these problems are of concurrent force system. Now state the equation of equilibrium for concurrent, parallel and general force system. So generally for concurrent, we have only two unknowns and we have two equations, summation fx0, summation fy0. For parallel, we have two equations that are summation fy0 and moment 0 if our forces are in vertical direction. So all forces are in vertical direction. If forces are in horizontal direction, then we have two equations, that is summation fx equal to 0 and moment about any point equal to 0. And for general, we have three, summation fx0, summation fy0 and moment about any point 0. So likewise, we have these questions for 3 marks. So this is all about question 2019. Now if you have not subscribed, subscribe channel Civil Engineering Technical Hub. Now we will stop here only. Thank you.